So, welcome to our first lesson in arithmetic progression. So, what is arithmetic progression? The number progresses as it goes. It's a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So, common example is see, for example, 1, 3, 5, 7, and so on. So, we see a pattern. The numbers progress and the difference between each subsequent number is just 2 in this case. So the 2 is known as the common difference between two subsequent terms. So the general form we write as first term as A. A is referred as the first term. Subsequent next term is A plus D. D is the common difference. Next is A plus 2D and so on. The nth term you see A plus n minus 1 multiplied by D. So the sum will be the n. Third term means A plus 2D. You know, A is one term, this is 2D you got. So if you take it as three terms. So third term consists of three portions like that. This nth term is A plus n minus 1 multiplied by common difference. A is the first term and we can get the common difference, t, by subtracting any term from the previous term, from the preceding term rather. So, so nth term will have a as one term plus n minus 1 times d. So totally it's n times. So n factors are there in this d. So we'll see the example. So in this case, 1, 3, 5, 7, you can make out A is the first term that is 1 and we write as common difference is 3 minus 2 that is equal to 2. You can check 5 minus 3 also is 2, 7 minus 5 also is equal to 2. So the next term, see the A, first term can be negative also, it is minus 12. So what is the common difference? Is equal to, so we will take some other term, you take minus 3 minus of minus 6 is equal to 3. Common difference is 3. So as it progresses, the terms will become positive. For example, after 3, you will get 0. Next time is 3. Next time is 6 and so on. So what is the next case? So A is equal to 15. The common difference is the figures are decreasing, you see. It's minus 4. How you get minus 4? So we will take it as 11 minus 50 like that. So we will try some more terms. The first case you see after 7 is 9, 11. It is simply all odd numbers. In this case 15, 11, 7, 3. What is the next term? 3 minus 4, Next term is minus 1. Next one minus 5, minus 9 and so on. So arithmetic progression, the number progresses in a particular fashion, with this specific difference. So many functions may behave in the same way. So this progression will be used in those cases. So we will try the next problem. So so there are different types of progression. So we will deal with it later. One is geometric progression. So the figures behave in the same way. It increases or decreases, but in a geometric proportion, not with a common difference. It's a geometric way. So it is multiplied by a fixed factor in GP. There's one more progression, harmonic progression. Harmonic progression is just the inverse of the arithmetic progression. For example, when arithmetic progression is 1, 3, 5, geometric progression is 1 by 1, 1 by 3, 1 by 5, and so on. In this case, the denominator is progressing, numerator is, so that is a difference in this. So this HP and all will come later. This is just a sample of HP. So this is AP, arithmetic progression. So this chapter will deal with the arithmetic progression first. So you'll see different combination, how the terms behave, what is the sum total of arithmetic progression, what is the nth term of an AP, and so on. So we'll write the first four terms. What is the first term is 10. Next term is A plus D, 10 plus 10, that is 20. Next term is 30, 30 plus 10, 40, so and so on. So next case we will try A. When A is equal to 4, the first term is 4. Second term is 4 minus 3, it's 1. Next is 1 minus 3, it's minus 2. Next minus 5, and so on. See, 1 minus 3 is minus 2. So next problem we'll try. When A is equal to is the first term. So what is substitute? D is 0. So each term is same. So this is also in an AP with different 0. Sometimes in an arithmetic progression, when difference becomes 0, the same figure repeats. Next example, A is equal to minus 1.25. A first term is minus 1.25. What is the next term? It is D is minus. When A plus D is, it is further, it is 1.5 minus. Next is minus 1.75. Next is minus 2, and so on. Next example is A is equal to minus 1. D is half. So A plus D is, next term is minus half. Next term 0. Next it's half, 1, and so on. Oh, you subtract some term from the, so see, half minus 0 from the preceding term, it's half. 1 minus half is half. 0 minus of minus is half. So next we will just find out how to find the common difference. So it's very simple. Any term minus the preceding term. In this, for example, we will see 5 by 3 minus 1 by 3. So 3 is gone. 5 minus 1 is 4. No, 4 by 3. You can check with these two. 9 minus 5 also is 4. 13 minus 9 also is 4. So common difference is D is equal to So we represent each term, for example, first term we represent by term 1, second term T2 like this, T3, nth term is Tn. Like we say, when we say Sn, it is sum of n terms. What about this next problem? D is equal to 1.7 minus zero point 0.6 is equal to 1.1. We can take it as 0.6. 1. See, in this case, 2.8 minus 1.1 or 1.1. Okay, here also is 1.1. So D is 1.1. So next problem, we will try to identify which are all APs, and we will try to write two more terms. Just by inspection, you see, 2 plus 2 is 4, here difference is 4, here difference is 8. So this is not an AP. Actually, it is a geometric progression. You multiply by 2, 2 twos are 4, 4 twos are 8, 8 twos are 16. So in this case, actually it's a geometric. That is multiplied by 2 is the factor. So about geometric and all will deal feature. So the figures are multiplying. So it's a geometric proportion. Next case, you see 5 by 2 is, what's the difference? 5 by 2 minus 2. It's half. 3 minus this 5 by this off. 7 by 2. What is 7 by 2? Minus 3. So if we take common denominator, 7 minus 1 is also equal to half. So half is the common term and the common difference. So it's an AP. D is equal to half. Write three more terms. 7 by 2 plus, it's to say 3 and a half. Next is 4. Next is 4 and a half, or it's 9 by 2. Next 5. It's 10 and a half. It's 11 by 2. 5 UZ. Like this, 5 by 2, 7 by 2, 9 by 2, 11 by 2. Here 2, 3, 4, 5. Okay, these are next four terms. So this is an AP. So next problem, number 3. It's minus 1.2 minus 3.2. So we can find the difference is 2, minus 2 rather. Here 5.2. Again difference is 2. Here difference is 2. Common difference is minus 2. 1 point minus 1.2, 3.2, 5.2. So we know the next four terms. Minus 1 point, minus 2. It is minus 9.2, minus 11.2, minus 13.2, minus 15.2, and so on. So in the arithmetic progression, the chances of mistakes are more. So we have to be very careful with this sign. When d is minus 2, so the figures, see, after minus 7.2, next term is 9.2. So the additions and subtracting we have to take care in these problems. So next case we'll see. This is minus 10, minus 6, minus 2. So we have to check all the terms, So minus 6 minus of minus 10, it's 4. So minus 6 plus 4 is minus 2. Minus 2 plus 4 is plus 2. So this common difference is 4. So we have checked all the 4 factors, Therefore, it is an AP. So after 2, next from 2 plus 4, 6, 10, 14, 18. Next to and so on. So we have done. So we will try some. So what happens if first factor is 3, next factor is 3 plus 2. So difference is 3 plus root 2 minus 3 is equal to root 2. We'll check with next one. Here 3 plus 2 root 2 minus 3 plus root 2. This is also 2. Here 3 plus 3 root 2 minus 3 plus 2 root 2. 3 and 3 will cancel. 3 root 2, 2 root 2. Difference is root 2. So this is an AP. So what are here 3 plus 3 root 2. Next is 3 plus 4 root 2. If you know the common difference, we can write all other factors. Next is, it's 3 plus 5 root 2. Next 3 plus 6 root 2. 3 plus 7 root 2. See, in this arithmetic progression, uh, not only this, all the sums, we advise students to apply their logic and check whether the answer is correct. That is how they should go. In mathematics, anybody can commit mistake. We may tell 4 root 2, I may write 3 root 2 there by mistake. So you will have to apply your logic and then decide, or it's better you yourself write the answer and check with this, so that you will arrive so you'll be sure you have understood the basic. That is more important. If you know the basic and you if you apply the logic correctly, you will get the answer. So we need not remember or mug up anything. Main formulas we have to remember. Formulas and how to apply the formulas. What is the meaning of the word? That we should, what is it, what do you mean by AP? Like that we should remember. So we'll try the next problem. See here 0.2, next is 0.22. 0.22 minus 0.2 is equal to 0.02. In next case, 0.222 minus zero point 0.2, it is 0.022. So D, this is not an AP. So this is not an AP. So difference is not same between two subsequent numbers. In the next case, 0 minus 4 minus, it's very easy. The common difference is minus 4. So how you arrive? For example, it's minus 12 minus of minus 8. So is equal to minus 4. Common difference where the figure is decreasing or increasing, that you observe carefully. So question number 8, you see the figure is half, 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 its figure is constant. So difference is equal to 0. So it is an AP. It's a constant AP, that is no problem. Next problem, A, 2A, 3A, 4A. So in this case, we will try to write the next four digit that is required, So next four digit also is minus half, minus half, minus half, minus half, and so on. That's all. It's next problem. A is the first term. What is a D? D is equal to 2A minus A. That is also equal to A. Either 3A minus 2A or 4A minus. All are A. D is A. So how you write the next for AP? So this is an AP because the difference is equal to A. What is the next 4A? Next 5A, 6A, 7A, 8A. Different, sorry, this is 8A. Difference between any two subsequent 8, 7A minus 3A or 6A minus A, all is equal to A. So 10th problem, this is 10th problem. A square, A cube. So the difference is not uniform, no? First difference is A square minus A. Next is A cube minus A square. They are all different. They are not same. So this is not an AP. Actually, so it's a GP, I told you. Geometric proportion. If you multiply A by A square, next A cube, to the power of 4, like that is geometric progression. For understanding, so arithmetic progression generally we will deal at length. So next other progression, will be similar. So the concept is same. One is here fixed. Common difference is common. In GP, the multiplication factor is same. In AP, it is 1 over the arithmetic progression. So we'll go to next problem. Problem number 6. Find the 30th term of an arithmetic progression. It is 10, 7, 4, and so on. So how exactly we find nth term? That formula. So in this case, how you find? We know A is equal to 10, first term. What is D? D is equal to minus 3. 7 minus 10 or 4 minus 7 is minus 3. So how we arrive the 30th term? What is 30th term we represent by, T30. Term 30 is equal to A plus n minus 1 multiplied by D is the formula. So what is A is equal to? A is 10 plus n minus 1 is 30 minus 1, 29. Multiplied by D. D is minus 3 is equal to 3 nines are 27, 2, 3 to 8, 87. So your plus is there. So it is minus 87 plus 10, it answer is minus 77. So in each problem, please check the addition, subtract again. You do it independently so that you can have a check on this figure whether it is correct or not. So don't try to remember the figures. So you try to apply the formula. So next from 11th term of AP, minus 3 minus half 2. The common difference is here. First you write what is the A. A is equal to minus 3. What is the D? It is 2 minus of minus half, it is 2.5. How you get? Or you try with that other one first, or you try with this minus half minus of minus 3. So the difference is plus 2.5. So the figure is improving, you have to add 2.5 or 2.5. So how you get the 11th term? A11, that is how we represent. A11 is equal to first term minus 3 plus n minus 1 multiplied by d. N minus 1 is 10. 10 multiplied by, so this you can take it as 2.5 or 2.5, you take classes, no problem. So this is 25 minus 3 is equal to 22. So in this arithmetic program, you try to see what is the logic. First term is minus, but subsequently, it's progressing towards plus. Minus 3 plus, here 11 means this is first term is one term. Here, you got 10 subterms rather. 10d. Sum of the n terms of an MAP. First term we represent by A, last term is L. So what is the sum? Sum we are represented by S, n terms of an AP is equal to first term A by 2 multiplied by first term plus last term. This is one of the formulas. This is similar to sum of n digit, n into n plus 1 by 2, sum of n numbers 1 to n. This formula is similar. A by 2, first term by 2 into A plus L. First term plus last term. Actually, this expanded form is A by 2 multiplied by 2A plus n minus 1 into D. L is equal to A plus n minus 1 into multiplied by D. So this is the main formula. Sum of n terms, sum of the n terms of an AP. Sum of n terms of AP. We represent by Sn. Okay. A first term divided by 2 multiplied by 2 times the first term plus n minus 1 multiplied by D. Or this formula we have to remember, and the first this formula we can prove this formula also in the similar manner in sum to n terms. So we have come to the end of the first chapter in arithmetic progression. Now we know the various general forms we use. First term is A, difference we represented by D, common difference, and nth term we denote by A plus n minus 1 multiplied by D. So if we know in this with conditions, one, we can find out the other. Suppose first term is given and D is given, we can find out the subsequent terms. Suppose a specific subsequent term is given and A is known, we can find out what is the term number, or sum of the AP. We can, if we know some certain things, we can work out the other things, unknown factors, we can work out. So in this, with this, we come to the end of the first chapter. You please repeat this problem to understand the various terms we are using. What even by a plus 2, what is this n minus 1, what is this d. So thank you for listening lecture in arithmetic progression. Please get into the basic principle in mind. So we can work out any problem. So again, thank you.